Welcome to the channel. Today we are going to see Theorem 10.1. The tangent at any point of a circle is perpendicular to the radius through the point of contact. First, let me draw a circle. This side I am drawing here. Okay, here they said tangent at any point. So we have to draw one tangent for the circle. So tangent in the sense it will intersect one point on the circle. That is the thing. So it is going like that. The point I'm taking P, intersecting point, center point of the circle I'm taking as a O. See, we have to say the point of a circle perpendicular to the radius through the point of contact. So the point is there now. When you draw one line to the point of the contact, it is making 90 degree like that we have to say, right? So we need to prove what? Let's go. Before that, what are the things that they have given? Let's write. So here they have given one circle. Okay, so let me write about that. So here let O be the center of a circle. Center of a circle, that you just write, and that tangent name I'm taking x y. So x y is the tangent. Let, so what is that? X y be the tangent of a circle. Okay, so this is I'm telling now. So what are the things we have taken? That also I'm writing. That point of contact means that circle and the tangent intersecting point P. So that you just mention one word. Okay, so P be the, let P be the point of a contact. Point of a contact. So that is the thing we have to write. Right now, what we need to prove? So we need to prove that OP, that OP means OP in the sense here radius, okay, that OP line is perpendicular to the XY, like that we have to prove. That is the thing. Okay, now what are the things I'm taking? Let's go one by one. First, apart from the point P, I'm going to take another one point like a Q. Q you can take left hand side or right hand side, but the point Q on the XY you have to take. Okay, so on the XY I'm taking here, that is a Q. Okay, so now you join this. So what I'm getting, when I join that line compared to the OP, OQ is a greater. Okay, so I'm taking, let Q be the any point on a circle. Any point on the circle. So the very important thing, that must be outside the circle. Inside the circle, if you are taking in the sense, because we are taking on the XY now, so XY will go inside. Then XY will not be a tangent, it will be a secant. That is the very important. So the Q point must be outside the circle. Okay, so Q be any point on the circle I have taken. Then join OQ. We are joining O and Q. Okay, so hence what I am getting, hence compared to the radius, compared to the radius, OQ is a greater. That how you will write actually. So OQ is longer than the radius. Longer than the radius. Okay, that is what is the meaning? OQ is a greater compared to the OP. So if you are taking some other point here, PQ, suppose if you are taking R, same thing will continue. If you are taking R, when I am joining this O to R, I'm getting what? Again OP. What is that? Here that OQ is smaller than like OR is a greater. But whatever, definitely that OP is a smaller only. So even if you are taking OR, that is a greater compared to the OP. So whatever the point you take, OP is a smaller. So what I am trying to say here, so which is the smallest point on the XY? Means compared to the length I am telling, OP is a small length compared to OQ. Like that compared to OR, OP is the smaller length. So therefore, I can able to write now OP is a small compared to OQ. Like that compared to OQ, OR is a small. If you are taking some other point also, the smallest length is which is OP. Then which is the smallest distance we have, that will make definitely 90° with the tangent. So hence we are writing, what is that? OP. Okay, so I'm writing here OP is perpendicular to the XY. Like that you complete. So this is this line. So we are writing a OQ greater OP, OR greater OP, and OP less than OQ less than OR, etc. We are writing that is the through that only we are telling OP is perpendicular to XY. Understand? So these things you have to understand. So this is one of the important thing. Okay. Now we'll go based on this thing. Next slide we are going. See, xi is a 10.1. First question, how many tangent can a circle have? This is very easy to say. A circle contain infinite tangent. So how I am telling infinite tangent? You just draw one circle like that. We are drawing. Here I can able to draw one tangent in the sense it will intersect exactly one point. Like that I'm drawing this side. This is also intersecting one point. So like that if you draw in some other point, it will intersect only one point. Tangent in the sense it will intersect only one point. When you zoom this place also, here also I can able to draw another one circle. Like that I can able to draw many, what is the tangents? So that only we are telling here a circle. Okay, a circle have infinite tangents. So therefore we are telling there are infinite. Okay, what is that? Infinite tangents. There are infinite tangents. Okay children, so that you need to understand. For what we have infinite tangent, there are infinite tangent of a circle. If you want complete in a perfect manner like that, you can write. Okay, so this is another one mark, like one more question only, but you need to understand how we are telling infinite. Okay, now we'll go to next slide. 2 mark. It is based on like 1 mark only. Like they will ask in a MCQ or fill in the blank, or in case study also. You just listen this. Fill in the blanks. A tangent to a circle intersected in dash points. So a tangent to a circle intersect at most how many points? We know very well. You see this tangent in the sense it is intersect to only one point. Here also see only one point. So tangent in the sense at most it will intersect only one point. So you want to write here 1. That's it. Understand? We are going next one. See, a line intersecting a circle in 2 points is called a dash. Generally, one line intersecting a circle in 2 points, that what? Let me show the diagram. You see here, I have a one circle. 2 points is there. So I am drawing one straight line through the points. Then this line called what? That is called a secant. Okay, children. That is called a secant, because if it is end inside the if it is end inside the what is that circle in the sense that we'll call as a what actually, yeah, just a minute. This is secant. Yeah, suppose it is ending inside the circle, that will call as a chord. This is chord will call. Okay, that will call chord. But it is going outside. It is a line. It is going outside. After intersect the circle, it is going outside. That we will call as a secant. Okay, so they said here line, not line segment. They said clearly here line intersecting a circle, 2 points is called secant, not a chord. Chord also will intersect 2 point, but it is not line segment. They said clearly line. When they given line segment, you want to say chord. If they given line, you want to say secant. That is the difference. Understand, children? Now we are going third. A circle can have dash parallel tangent at most. What they're telling you, just listen carefully. A circle can have dash parallel tangent at most. So I have a one circle. I have a one circle here. So this circle at most how many parallel tangent we have? See, I'm drawing one tangent here. Here I'm drawing. So this two tangent can be parallel. Okay. Suppose another side I'm drawing like this here now, and this also can be parallel. But at most two only we have. See here and here. That is, and this side one, this side one. This is together one pair, and this is together one pair. At most how many we are telling now? One pair. One pair in the sense two tangent. Okay, children. So you want right here 2. That is the thing. Okay. Next we are going for the common point of a circle to a circle, and the circle is called, see, common point of a tangent, sorry, common point of tangent to a circle, and the circle is called, see here, you see this. Now common point, this is a circle we are drawing here, and this is the tangent. So tangent and circle common point, na, this point name they asking. I told you already this name point, a point of this name here I have mentioned. What is that? In this theorem, point of contact. The PBD, what is the name? Point of contact. The common, what is that name for both circle and tangent? Na? That is called point of contact. Okay, point of contact, that you have to say, right, children? So you have to understand these things by this diagram. Now we'll go to third question. Okay, so what third question says, let's see one by one. We just read this. A tangent PQ at a point P of a circle radius 5. First we'll draw one circle, and we have a one tangent. Okay, we have one tangent. This is the center point O, right? Radius they said 5 centimeter clearly, right? A tangent PQ at a point P of a circle, they said. So here that intersecting point they said P we are taking. Radius they said 5 centimeter. Okay, let me take that 5 centimeter. Okay, meet a line through a center O at a point Q. So we are drawing one point Q. Suppose here I have a point, outside I have a point Q. That Q point O point when I joining, it is meeting in the O. That OQ they have given clearly. What is that? 12 centimeter. This is a 12 centimeter. What is the length of PQ? This length they have asking. So we know very well that OP length definitely perpendicular to the tangent, because the theorem, what is that, 10.1 says what? The tangent to a circle is perpendicular to the radius through the point of contact. That you need to remember. See, now 90-degree opposite side we know hypotenuse. So that I'm going to use the Pythagoras theorem. Okay. So Pythagoras theorem says what? In a right angled triangle, square of the hypotenuse side. So hypotenuse is the OQ, which is equal to sum of the square of the other two sides. So OP square plus PQ square. Let's write that. OQ value we have a 12, which is equal to OP we have 5 plus and PQ square. Now 12 square the value 144, 5 square the value 25 comes to opposite minus 25, which is equal to P cube square. When I am subtracting this together, I am getting 119, which is equal to P cube square. Square goes to opposite root. That's it. So this is our required answer. Where we have this one? Here we have option D. So option D is our required answer. Understand, children? Right. We will go to the next. So fourth one, Draw a circle. So let's draw the circle first. Okay, we did the circle and two lines parallel to the given line that such that one is tangent and the other. That is the thing. Okay, listen carefully. Two lines parallel to the given line. So given line I'm taking. Given line I'm taking here. So this is my given line. You just write here, no problem. Given line like that, you just write. They said two lines are parallel. They said, what is the parallel? See, such that one is a tangent. In the this two line, one is a tangent. So tangent you just draw. So this is the tangent we know. You just write here, this is tangent. So in the two line, one is a tangent and other a secant. Secant in the sense that we know very well. So it is intersecting a circle at a 2 point. After that, it will go outside. So this is the secant. And they said clearly secant line and tangent will be parallel. Okay, parallel. That is the thing. Then we have to say the given line also parallel to the this remaining two line like that. Okay. Now see children, draw a circle and two lines parallel to the given line. Yes, see, secant parallel to the tangent and tangent parallel to the given line. So like that, when it is a parallel, so like that you have to draw. Okay, that is just a drawing work only. Simply you draw one circle and one secant, one tangent, and one given line.